The asteroid Apophis is getting closer to our planet with each orbit around the Sun. This gigantic space rock with a diameter of approximately 340 m has been considered potentially dangerous. According to NASA, those asteroids that approach the Earth at some point at less than 7,480,000 kilometers and measure more than 140 m in diameter are potentially dangerous. Apophis meets those requirements. There are possibilities of impact against the Earth. The possibilities of impact are real, and we will analyze how this may continually change over time. Today we are going to learn about the real and updated data we have about Apophis and other space rocks. You will see that the situation is very different from what we knew a few years ago. There is a real danger. It is no joke. Apophis is an asteroid because its orbit is close to the Earth with an inclination of 3.3 degrees and varies from outside the orbit of Venus to just outside the orbit of the Earth. If it were to impact our planet, the consequences would be devastating. According to the Century Risk Table, an impact would release kinetic energy equivalent to 1,200 megatons of TNT. That is equivalent to 24 Tsar bombs. If it hit sedimentary rock, it would make a 5 kilometers crater, and the shock wave would extend a radius of 70 to 50 kilometers. An earthquake and the total destruction of buildings, fauna and flora in a radius of 30 to 40 kilometers. And 30 seconds later it would collapse under any construction 150 to 200 kilometers away. If the meteorite falls on a populated area, it could completely destroy any of the largest cities in the world or a state like Mexico. These types of asteroids impact the Earth every 80,000 years. There are no records of asteroids of that size since Homo sapiens appeared, more than 300,000 years ago. Which means that with each passing day the risk of impact increases. I am sure that you have seen videos and websites where it is said that Apophis is going to impact the Earth in 2029 and others in 2036, and that it is going to destroy everything, as well as others that say that the possibility of impact is zero. So who is right? The first thing you have to know is the real danger that Apophis has for us and what its route is. Apophis moves in an elliptical orbit around the Sun, at almost 30 kilometers per second. At this moment it is 1.58 astronomical units from the Earth. That is just over 236 million kilometers. If you look closely you will see that it is now between Venus and Mars. In its orbit it sometimes crosses the Earth, and that is where the danger is, since it is a matter of time before Apophis and the Earth coincide. But what's so special about this asteroid? And why all the fuss? Apophis was discovered in 2004, when an initial observation estimated that the chances of collision with Earth were 2.7% on April 13, 2029. In a scenario as vast as space, 2.7%, these are possibilities to take into account. In that year it reached the Turin scale 4. This means a high risk of collision and damage at a regional level. Such a value had never been achieved on an asteroid. From there, various media inflated the news to say that the end of the world was near and that Apophis is the asteroid of the apocalypse. At the high speed it travels and its considerable size, it represents a potential danger to be taken into account. It is as big as 3 football fields, about 340 m according to NASA and 370 m according to other sources. It is currently the most dangerous asteroid known to approach Earth. Faced with so much commotion, NASA prepared the OSIRIS-REx mission in 2016 to better study asteroids and estimate the risk of impact. Returning a sample of the asteroid Venu, now its mission has been extended and it is heading to the aforementioned asteroid of the apocalypse. Apophis should arrive a few days after April 13, 2029. The measurements of the asteroid were recalculated with the Goldstone radar and the Arecibo telescope. According to NASA's Jet Propulsion Laboratory, the chances of impact are practically zero in 2029 and NASA scientists lowered Apophis to the zero Turin scale, but the chances of collision increased to 1 starting in 2036. And it had better be that way, because the situation we could find ourselves in would be very unpleasant. An impact with the Earth and the OSIRIS probe on its way to rendezvous with Apophis, there would be nothing to observe. In addition, at the moment we do not have any means to deflect this type of large asteroids, but we have some significant advances. We have managed to divert the orbit of the 160m dimorphic asteroid, about 32 minutes. It is a minimal detour that could be sufficient on other asteroids, and they deviate years in advance to avoid a collision. If we want more certainty, we should do more tests with larger asteroids. As you know, the solar system was born from a large molecular cloud, and a large amount of material formed the planets and the Sun, but there is a lot of leftover material. Some form rings of material like the asteroid belt, and others have orbits around the Sun. Some intersect with the Earth as Apophis. Thanks to various observatories such as the Green Bank and Goldstone telescope, we have precisely calculated the trajectory of Apophis and what will happen. An estimated date of approach to Earth is April 13, 2029. On that day, Apophis will be seen in the sky as a star of magnitude 3.3 and can be seen from Europe, Africa, and Western Asia. The approach will be about 32,000 kilometers from our planet, very close to the geostationary satellites. At a cosmic level, it is a ridiculous distance. Experts predict that in the event of an impact, it would occur in a very wide area, between the Kamchatka Peninsula, Russia, and Venezuela. Davide Farnocha from NASA's Near-Earth Object Studies Center has reduced the alarm and tells us that there is no risk of impact, at least for the next 100 years. Thanks to recent advances with advanced optics and radar observations, the margin of error is now only a few kilometers until the year 2029, which means we are 99.99% certain that Apophis will not impact Earth. As you see, certainty is never 100%, and the possibility exists. The B612 Foundation, whose objective is to detect dangerous asteroids, continuously follows Apophis in case the impact were to occur, and thus develop a diversion strategy with sufficient advance notice. Although space agencies do not consider a real danger of impact for the year 2029, there is a margin that astronomers call a risk trajectory. However, although the next few years do not entail any risk for us, there is something much more worrying that I will talk about later. You may have asked yourself, how are asteroids detected? How can I trust NASA, and how can they know with such precision the trajectory of an asteroid? First, telescopic observations are made. Astronomers use ground-based and space-based telescopes to observe asteroids, recording the precise position of the asteroid in the sky at multiple times. These observations provide data on the position, speed, and direction of the asteroid relative to the background stars. Another method is radar. Radar is used to more accurately track near-Earth asteroids. By sending radio pulses toward the asteroid and measuring the time it takes for the signal to return, scientists can determine its distance and speed with great precision. Orbital dynamics models. Astronomers use complex mathematical models that take into account the gravitational influence of planets and other objects in the solar system. These models allow us to predict the future trajectory of the asteroid with a high degree of precision. Next is historical data. Historical data from past observations of asteroids are used to refine models and improve future predictions. You should know that objects in space have fixed trajectories, but any change in their orbital conditions due to the presence of a significant mass could change their trajectory. Unexpected changes may occur. For example, collisions with another asteroid. Another risk is the Yarkovsky effect, as a result of interaction with sunlight. When an asteroid is rotating, it causes a very peculiar effect as the illuminated part heats up. When it darkens, it releases heat. This heat causes it to change its trajectory over time. They are very small but significant changes on time scales of years. You have already seen that we cannot control all the gravitational parameters millimetrically. That is why we can never be 100% sure that an impact will not occur, but 99.99% certainty. Percent is very reliable, so we can say that the chances of Apophis impacting the Earth in 2029 are extremely low, but not zero. And here comes something important: the risk of Apophis will increase over time. In 2036, the risk is raised to scale 1, which means extremely low, but in 2068 it is raised to yellow level, an unlikely collision. And even if there were an impact, this asteroid is not going to cause the end of the world, nor would it wipe out the human species. Its size is not large enough to produce global changes and change the climate. Collisions have occurred in the past and will occur again. We must be prepared. The Chicxulub asteroid, 66 million years ago, released a power of more than 100 million megatons. A 10 kilometers asteroid would extinct most species and wipe out a large part of humanity. And here comes the worrying thing. We have discovered more than 21,000 nearby objects, and 2,000 of them exceed 140 m. That is, they are dangerous for us. But the ones that interest us are the ones that we have not yet discovered. There are estimated to be more than 5,500 asteroids like Apophis, between 300 m and 1 kilometer in diameter, of which about 4,300 have been discovered. This means that we have yet to discover 22% of them, and the worst thing is that about 20 are wandering around. Undiscovered asteroids that exceed 10 kilometers in diameter, which means that the risk of impact exists, and that we could not detect them in advance. Asteroids larger than 10 kilometers could cause a mass extinction. If we go to the total population of asteroids, it is even more worrying, since there are dozens of millions of them from sizes of 1 meter to more than 15 kilometers. If, as I have told you, we only know about 21,000 close to Earth, we are missing at least 99.9% of them. That means Apophis is just another asteroid in the vast void of space. The Tunguska bolide in 1908 was produced by an object measuring 60 to 190 m, and although it did not reach the Earth's surface, its power was 25 megatons and it destroyed 80 million trees, unleashing a cloud of dust that reached 16 kilometers in height and spread throughout Russia and much of Western Europe. The Kalievins bolide in 2013 was another case of a meteorite passing through the atmosphere undetected. A 20 m asteroid disintegrated at an altitude of 30 kilometers, releasing an energy of 400 kilotons, injuring 1,500 people, caused by the explosion of broken glass, and as many people were blinded by the light, since the brightness of the meteorite exceeded 30 times the light of the sun. They are evident evidence that we do not know all the asteroids in the solar system, and those unknown asteroids are the ones that really worry us, as they can catch us off guard and cause catastrophes. The risk is real. The asteroids that continually make headlines and news are known asteroids that generally pose no immediate risk. Asteroids and comets enrich planets with valuable elements, and sometimes transport elements such as life, but they are also carriers of catastrophes and mass extinctions. They can be angels or demons. The space exploration of these bodies can not only help us learn more about the formation of the planets, but also to refine the precision of the orbits. In addition to asteroids, you can obtain great resources. An asteroid like Apophis may have precious metals such as gold, platinum, and other rare metals such as iridium, water, and volatile materials that could be useful for future space missions. With each new investigation and each step forward in our exploration of the cosmos, we get a little closer to understanding our place in the universe and the role we play in this amazing cosmic dance. Hush.